Hey, my name is Will. Welcome to TroubleTelevision. Today we are going to look into another Go topic, a more exotic topic at that. I'm a big Lua fan, so a few years back I actually looked into how I can extend Lua with Go. So that is what we are going to do today. Okay, so first I checked out the Lua repository from GitHub because I need the C and header files from Lua itself, so I actually can extend it. Then I actually need to import C already because we need to use CGO, so the possibility to write C code in Go directly. First things first, we need to add some linker flags here so we actually can guide the linker where the Lua resources are located. We use source here because we want to use the current directory. And then we are actually going to write some code already that will link our extension into Lua. So first we need to import the Lua lib itself or the Lua header file itself. And we also import standard IO here just because I want to have like some output in a second. Then I just create a function which is called register my add-on. This function can actually be named anything. It is just supposed to be like the container function where everything that we need to do to the state will be set up. Return 0 in this case. That means that actually when you call this function, it doesn't return anything. It just is called. And then we do like just a printf here to showcase that we actually can do something. So next thing we need to do, this is actually like the imperative part to writing a Lua add-on or Lua extension. You need to create a function which is called Lua open underscore and then your name, which just accepts a Lua status argument and returns a integer. And in there, we actually call just the register my add-on function we just defined. And then we need to export it because lowercase stuff is never exported in Go. And since we need to want to export that to use in Lua, actually, like in the shared object, we need to do like an export comment. Then we create a test Lua file where we say require my add-on. And then we are already back in the CLI where we run go build with a build mode C shared, which will output a shared object that we can use. So we name it here my add-on because this is what Lua is looking for when you would require like something like that. It will look like for SO files. And then we use main go as input. As you can see, there were no errors. So now we actually can see that we have like my add-on.h and my add-on.so, which are created by the compiler. And then we can run the Lua test file. And as you can see, we get hello world as an output. Okay, after that, we need to extend it a little bit more because this is quite a boring extension. So what we are going to do now is we create a new table. This will push, because Lua works like a stack, we push a new table to the state. We push a string, we push called fetch in this case, and we push a C function, which will be referenced to fetch because in the next step, we are going to say set table -3, which means that we set the index back to before the table was created, and we assign the properties we define afterwards as keys and values. Then we need to define the fetch function we just referenced, of course. This will also be just like a simple C function where we actually do like all the magic. Before we do that though, I added a type definition here for a string, a const char in that sense, because it is easier to handle that when you're working with the Lua VM. So here we are just defining a parameter basically, which is called URL. We are using an aux function for that Lua L check string, which actually will retrieve from the Lua state a string parameter. And if this is missing, there will be actually an error thrown. After that, we are calling a function which is called goFetch, which should return an int as well. And we are going to define this function as an extern function, where we actually say that we accept a Lua state and a string, so in our case a Go string as an argument and return an integer. And this is actually where it comes in handy that CGO allows basically a mixture of C and Go, because now we can define a function which is called goFetch in Go. And since it is like in the same shared object, it will be exported to C as well to be used. All right, so let's define the goFetch. It is just like a Go function, which accepts like the C type Lua state and C, our custom Go string, and returning a C integer. And since this is also like a function that needs to be visible in the shared object, we need to export it as well, because else it would Go would just like export as Go would, like basically the uppercase, starting with uppercase, the capitalized like functions. So we need to put an explicit export comment in here. And then we actually can go into compiling again and executing the Lua script. But actually there shouldn't be an output because we forgot a little something to do. Okay, so the first thing is, since we actually expect a table now, we need to adjust like the Lua script where we actually expect a table and call a function on it. And the second thing is that the register add-on now needs to return 1, because the return value is always the thing that Lua will pop from the stack. So if you have 0, it will pop, it doesn't pop anything. If you have like 1, it will pop 1 argument, and so on. So now we are actually setting as a response to the table, and then we need to adjust the go fetch, of course, because we are tired of like having just like printing functions. So what we are going to do now is we're actually converting the string we are get passed into a Go string, and then we use like the Go standard lib to actually do something useful. In this case, we are just expecting like a URL that we can fetch. So here's like just some error handling, just to be precise and complete. And here, maybe like just a quick note, I actually do like a Lua push nil thingy where we push like a real response on the stack, and we lock on error the error on Go level. So this would mean that a fetch always returns like still in error cases like a nil value that you can like react on. Same here, we need to read all like from the response, like the body. Same thing here, we need to have like some error handling. And this is actually like lazy error handling. You could also do like that you return, for example, 2 arguments for the Go fetch in Lua itself. So you could have like the response and the error as well, because Lua accepts like multiple return arguments as well. But we are doing it basically the old school way and just logging from Go and just expecting that there is like a response or a nil. Okay, here's another thing. Since we read all the body, we need to convert it to a C string that we actually can use. And this is done by a handy function in CGO as well, which is called CString. And the CString function actually uses like memory allocation on C level, as far as I remember. So what we actually need to do, like in a second after we do like some error handling for the closed body, we actually need to free the memory ourselves. And this is easily done by defer C free unsafe pointer, and then we just pass on the body basically. And then we actually have like a C string body that we can use. So we use again like a Lua push string, which will push to the stack like the response. And then we say, all right, I want that you use like the last argument on the stack as a response thing. So now we actually can adjust the Lua script and print like basically the response we are getting from fetch, which should be like the body of the page. But I remember that I forgot something. That's why we add like here the standard lib import, because we need that to actually do like the C free. And then we actually need to add the state to the push string function we just used to actually tell Lua where to push basically the response body. Then we compile again, run the script, then we should see the Go body. And that's it. Thanks for watching.